Hello and welcome to another Solana tutorial. Today we're gonna talk about reentrancy. Reentrance. Basically, a program calling another program calling the first program again. Because I think that's illegal. But that's also what I thought about self-CPIs until I proved myself wrong. And in fact, I think that's the reason why I thought self-CPIs are not possible. I think I was thinking about that. And in my self-CPI video, I didn't explore that and I might have made a few wrong assumptions. So today I want to clear them up. I think that was in the video with the self-CPI where we analyzed which CPI depth we're in and where we tried to figure out if we're on top level. And the way they did that was to check if the program we're in is the same program as the program of the instruction. And that might even already be the reason why reentrancy is not allowed, that you can make sure that you're actually top level. And we didn't explore that if a program can call another program that calls the first program again. It can call itself, but then at least it must know that it called itself, because otherwise, I mean, you're stupid or it's a weird bug. But yeah, let's just explore reentrancy today. That's what I feel like doing, and that's gonna be interesting to me, and I hope that you also learn something along the way with me. So let's go and have a look at programs calling programs. And we're gonna learn a bunch about other things as well, you know, as we usually do, because we'll have to write Solana programs and we'll figure things out along the way. Helios docs say reentrancy is inherently limited on Solana due to its execution model. Solana runtime restricts CPI to a maximum depth of 4 and enforces strict account rules, only allowing an account's owner to modify the data. These constraints prevent reentrancy attacks by limiting direct self-recursion. But that's what we had a look at. We can do self-recursion and ensures the program cannot be involuntarily invoked in an intermediary state. The attacker's mindset in exploring Solana programs. I like it. Maybe we're gonna do a whole other video on that. Last time, when we did the self-CPI, this is what we had. We're just gonna recycle that. And we're gonna pass in the depth as instruction data. We return at depth 0. Whenever the program is called, we say what depth it is, because that's something that we add. And this is the program that we wrote in the self-CPI video, so you can watch that. Basically, there we were just, you know, calling ourselves. And we were calling ourselves because I put that in as an account, so I don't need to do many modifications if what I want to do is build a program that calls other programs. I basically give it a list of programs and then it should, you know, CPI through those. And all of them will be the same program, really, with the same code, but different programs. So basically we're going to do the same thing as we did here with a self-CPI, except now we're jumping between programs. So program A gonna call program B, gonna call program A. And we're gonna check if that's possible, because I think it is not, but I've never tried and I don't know what the error would be. So therefore, we gotta try. I mean, that's what we're here for, to learn, right? And to have fun with Solana. I mean, that's just me, but okay. Good. Do we need the instruction sysvar? Do we want to be able to check that we're top level and stuff? You know what? I'm gonna say yes, but not yet. And I'm gonna put that on number 0. So the first one is just gonna be my sysvar instructions, the first account. And we're gonna deal with that later. Data account, nah, I don't need no data account for now. And then the program to call will be account number 1. And I increase the depth in the instruction data. And then we just call that program. Obviously, again, with first account being the sysvar. And then that program I will not put in here anymore. Also the data account, I don't need that. So also here basically just gotta clone the sysvar instructions. And the way I know how I gotta stop is if there's no more program to call. So if I'm not gonna do it with a depth, I'm gonna do it with the accounts length less than or equal to 1, and we say okay, because no more program to call. That's what my program looks like for now. Basically, really just doing a CPI on a program. And let's start with doing a self CPI again, because that's what we know. And for that, we got to deploy this. Let's call this one, I've got a def, and then I'll do program A, and then later we'll do program B. Brrr. So let's go to devnet and set our key to the def. See if we can get an airdrop. Nice. See if we can build it. No, we cannot. Oh, yeah, dependency. I'm missing the Solana program dependency. Like that, I could build, and I have my deploy stuff. I'm gonna drop this. Let's copy from the keys the A program into target deploy key pair. Yes, show private keys. Why not? And then say Solana program deploy target deploy this program. There we go. Program A XD is deployed. Now let's call it. And also that, you know what, I'm also just gonna copy that. This is our program ID. We don't need to create an account. And all we're doing is we're gonna call this with sysvar instructions at the top, and then the program that we wanna call, which is again our program. So we're doing a self CPI. Yeah, that's it. Create, sign, simulate, and if I can simulate, I send. And I don't need that. I mean, so far so easy. Let's try. Call program. There we go. I'm getting success, and I can send this. Did they change that? Whoa, they changed that. Explorer looks a bit different. Wow, they changed stuff. It's like smallest UI changes, and I'm like, ooh, I liked it better before. Classic. That's what my brain does. No, it's actually it's nice, but it's like I noticed that something is changing. Okay, anyway, we called our program A and said, hey, call program A again. And so in the inner instructions, we get another call to program A, this time with instruction data 1 as the depth. So that's how we know which depth we're in. So first the program is called on depth 0, and then the program is called on depth 1. And if we look at it raw, we also see which program is called. It's this one. Should I also log my program? Yeah, why not? Let's do program letter from the program ID. This is a pub key. You can do toString, which is not particularly efficient, but we don't care about efficiency at that point. Oh yeah, sorry, we're in Rust. Let's see how that would look. I wanted to say program A called, and I get the A from the first letter of the pub key. I think that will work. Yes, there we go. That's what I want. Program A called. We're in depth 0. Okay, good. And then there are no more programs to call. And see, my idea is that at the client, so when I build the transaction, I can say, okay, and then you call this program again, and then you call this program again. That's what I want to be able to do. So I need to adapt a bit here to also put in the remaining accounts. It's a bit easier to work with remaining accounts in Anchor than it is here, but I'll just do it manually. Wait, Solana program had much nicer than this. There was something with next account info. Account iterator is accounts iter, and then, okay, yeah, that's what we're gonna do. And then instead of this, we say, and this is a result or a program error. So if we don't have a first account, then we get the program error. And then we also don't need to use the length, but we just get the next one like this. Program to call. No, actually, the maybe program to call is this, except we don't question mark. So we keep the result. And if is okay, no, is error, then there's no more program to call. So we don't throw the program error. We don't raise it. We just say, okay, no more program to call. And otherwise, the program to call will be this maybe program to call. And we unwrap this, because if it's not error, then it's okay. So this unwrap should not fail. That's the same thing that we had before, just, you know, written a bit differently, working with those next account infos. I think this is actually a bit less compute efficient, honestly, because we build the result and then we use, you know, but, you know, again, I'm not trying to be compute efficient. So far I didn't gain anything, except that I have this iterator now. It's simply a wrapper around that returns a program error instead of an option. So actually, yeah, that it's pretty useless since I want the option and not the program error. I only want the program error here. So more compute efficient and cleaner would be to say next here, and then I get the option, and then if this is none, then there's no more program to call, and if it's some, then we unwrap. So that's the more compute efficient version. But it's only, you know, a little bit, and it would have been fine otherwise, but since it's just a wrapper. But hey, we're doing a little bit of Rust here, such that you learn, you know, you can pick my brain a bit, or I pick my brain and you can watch. Whatever. And just to prove, you know, I want to prove that this is more efficient, so let's do Control C again. It's not much more efficient, but like a few compute units. Like literally, I don't know, I guess like 20 compute units or some shit like that. Let's build SBF and deploy and call. Let's do all in one. Deploy, and then we directly call it. There we go. Look, that gives me success, and it consumed 25k 818 compute units. It's still only doing 1 CPI. But if I now go to the optimized version and I build, deploy, and call that, I think it's gonna be 25k 700 something. Nope, it's 1-to-1 the same. Literally the same compute units. Okay, so it doesn't really make a difference, does it? I still kind of like this version better. So let's use that one. Okay, so I was wrong. I admit that I was wrong. It does not make a difference. At least not in the call that I'm doing. So apparently it manages to, I don't know, optimize it away, that change. Creating the program error is not more than creating an option. Well, whatever. Let's make progress though. Making progress. So we want to be able to call more. So we need to again put the rest in there. So I'm gonna temporarily save the accounts. I'm gonna go account matters be this. So we start with that one. And then how do you write the for each with an iterator? Account in account iterator. Is that, can I do that? Looks like it. Account matters push. And now I will again need an account meta like this. Except I'm not using the sysvar, I'm using this account. The key, is it signer, is it writable? I'm just gonna push that into an account meta, or create an account meta and push that into the account metas. And those account metas I'm then gonna put here. That's the first part. And then I also need to put it all down here. And I'm afraid that it's not gonna be enough. Can I remove something from a slice? No, I cannot, because a slice is just, it's the cleanest way to do this. Because I don't think that I can do accounts. I wish I could just give it all the accounts, but then I have one too many in there. So I will have one more than here. But I'm gonna see what the error is. So try and call this. Oh no, that actually works. Maybe just because I have the same one every time. It's always program A. We'll fix it when we get to the error. So basically we see now program A is being called. Depth 0, call it depth 1, 2, 3, and then no more program to be called. And we basically define that because we say, well, first CPI into our program A again, then again, well, let's call that program A. There we go. So we call program A, program A, program A. If I were to just do it twice, then I would just go depth 0, 1, and 2, and then there's no more program to be called. So that stuff is working. Let's do the same with program B. So let's just try if I can call a program B. That should be possible because, you know, there's no big deal in just doing a CPI. But for that, we gotta move the program B key to the target. Or I could also alternatively say use this key. No, it's easier to just move it. Let's see. We are deploying program B and, oh yeah, hold on. Hey, I gotta put the right program address here. And then if we call it, then there we go. Program A calls program B, depth 1. And then program B has no more programs to call. Success. Good. So far, so good. But what happens now if I tell the programs to also call program A again? And this, ladies and gentlemen, and everybody in between and above, this is what the video is actually about. Is this possible or not? Can I make program B call program A again, or is it gonna fail? The suspense. Okay, I'm gonna try. It's not gonna work though. I'm sure that it's not gonna. I was sure that it's not gonna. Oh wow! Look at that! I've never seen that before. Cross-program invocation reentrancy not allowed for this instruction. Wow, it even understands that. It's literally reentrancy. It's part of the error. Wow, I didn't know that that would be the case. That's cool though. That's very cool. But also it kind of seems like the thing I've been doing with just putting all of the accounts here is just fine. I invoke with account infos. Those account infos don't even need to be in the right order or like the same order as the account matters, as long as all the account infos are in there, even if it's one more. That actually seems to be fine. I thought I would still have an error here. Okay, anyway, I need a program C. C. Okay, and then we like to move it. Let's deploy a program C. We're still not using the sysvar. I will eventually, maybe. Then call a program C first, just to prove that this also works. If program B then calls program C. There we go, that works. So yeah, that means that this weird thing with putting all the accounts here is just fine. I don't even need to clone any of that. That's fine. Cool. So program A calls program B calls program C. And C has no more programs to call. But what if program C would now call program A again? Let me guess, this is the same reentrancy error as before, just that it's not directly from B, but I'm pretty sure the runtime also checks that. And yes, of course, the runtime also checks that. Program C called, and then program C failed because cross-program invocation reentrancy not allowed in this instruction. And then that error goes right to program B. Cross-program reentrancy is not allowed. Goes right to program A. Cross-program reentrancy is not allowed. Why? Because when I'm invoking, I'm just raising the same error that I get from here. I could have my own error, such that program B and A would then, return something else or whatever. But otherwise, they just throw the same error. They just raise the same error. I think in Rust you raise and not throw, but whatever. And yeah, then we get an error. Cool. Yeah. I mean, is that it? Because I mean, now we saw what's happening. We see there is a cross-program invocation reentrancy not allowed for this instruction. Obviously, I could have another instruction that does it. If I have another instruction and I don't call the program A here, this is what fails. But if I had another instruction where I call program B directly and program B then calls program C and then program A, that will work. That's no issue. So there I get success. Oh, that's a lot of logs. Because that all works. And then here program B is invoked at level 1, so depth 0. They start with 1 and I start with 0. But it is the same thing. I mean, not really. 1 and 0 is not the same thing. It's off by 1. But yeah, I'm doing the computer science way of counting and they doing the normal numbers way of counting. Yeah, it also looks nicer like this, admittedly. But whatever. So yeah, if program B calls program C calls program A, there's no reentrancy here. That's all fine. Because those two are two separate top level instructions. The program A and the program B. And then it calls C and A again. So, I mean, so far so good. But I'm not done yet. I'm so not done yet. I mean, now we know that we can't do reentrancy. A top level program cannot be invoked again through CPI within the same instruction. But is that also true for, I mean, it should be, but I don't know. So let's try. What if my program A calls program B, calls program C, calls program B again? So my question is it just a top level thing? You can't call the top level program anymore? Or can you just not do any reentrancy? I don't know. Let's try. My guess is I can't. Yeah, wait. Oh yeah. So program C fails because it can't call program B again. Which, you know, makes sense because otherwise you could just have another top level, call it, and then it's suddenly possible. That would not make any sense. So this is not done just to prevent figuring out who is the top level caller, because that's the entire reason why I had the sysvar instructions here. We want to do this thing again. We load the current index of the instruction. Maybe I want to figure out what that is. Like, there's instruction in this, because last time there was 2 and I was so confused why it's 2. But yeah, maybe a good time to look into that. But current top level instruction. Then we get the current instruction that we're in. So the index is just for me to check what the index is. And then if it's the same program ID as the one that I am currently in, then I can say this is a top level instruction. Or our program was called again at an inner instruction. We can be more precise. Or our program did a self CPI, because otherwise it would be reentrancy and that's not allowed. Then the instruction data, yeah, whatever. So now this is fairly accurate. Damn, now I need to deploy that to all the 3 programs. Ugh. Deploy it to A. Oh, did I move it? No! No, I made a mistake. Shit. Oh no. Oh no. No. Damn it. What I did is I moved the keys instead of copying it such that I still have it like I did with the A. So the A I can still do. But the B, hey, but is it? I think it should be enough because I have the authority. I don't need the key anymore to redeploy because I'm set as the authority. So it should be sufficient if here I just provide the program ID and not even the key. That should also work. Okay, good. So it's not lost. Okay, never mind. It's all good. All good. Otherwise, I would have needed to grind a new key and redeploy to a new address. But we can still use this one. We can still deploy to this because I'm set as the authority. And I didn't delete my def key pair. Good. Okay. So we deployed to A, B, and C. Let's call it again and check the logs. There we go. Now program A is telling me this is a top level instruction. Instruction index 0. Oh, there we go. Instruction index 0. That's what I would expect as well. Oh, I probably had instruction index 2 because I did 2 calls to the compute budget program or something like that in the previous video. That's what confused me there, probably. So yeah, that makes sense. You know, we start at 0. Like with the depth, I start with 0. Instruction index 0, and we check the program ID. It's the same as the one calling. So then we know, oh, this is the top level instruction. Or a self CPI, because I can do like self CPI should still work here. If I'm not calling program B, but program A, then that should even all work, right? I do first a self CPI and then calling other programs. That should just work. Yeah, there we go. That just works. But in the second one, program A still thinks that it could be a top level instruction, even though it's not. But this is because there was a self CPI. And the thing is though, if you CPI into your own program, you should be aware of it though. Like, because you literally invoke it with the program ID that you put in here. And if that's your own program, come on. Then you either have a bug in your program if you don't want that, or you explicitly want that. Like I, in this case, explicitly want that to do this self CPI. And the self CPI works just fine. I can self CPI into my program and then still call others. But I cannot then anymore come back to program A. I can do one self CPI, but then once I go to program C, I cannot come back to program A. This is a cross-program invocation reentrancy not allowed error. Okay, so we learned that that's not possible, that you can't do that, but we still don't really know why. Yeah, for security. But why exactly? Like, what's the attack here? Like, why do we need that error? Just gonna Google it and see what comes up. Another notable difference is that reentrancy is not allowed except in the case of self-reentrancy. Somebody knows what they're talking about. Let's see that. Again, there's so much more that I could have a look at. Oh, that's the classic bricking. Okay, but where do you write about re-entry? If an inner instruction returns an error, the entire instruction fails. Yeah, that's, I think, a design choice as well. Reentrancy is not allowed except in the case of self-reentrancy used for event emissions. Okay, so that's what we've been using it for as well. Reentrancy for event emissions, which again feels a bit like a hack, but you know, whatever. Okay, but it also doesn't tell me more why reentrancy is otherwise not allowed. Why is it not allowed? Due to its execution model and design choices. Yeah, well, why did you make that choice? Preventing direct self-recursion and ensure... Well, that's wrong. Probably was fed the wrong data from somewhere. Although Solana programs are not typically vulnerable to reentrancy, it's good practice to avoid complex interactions with a single transaction that could lead to unexpected behavior. Reentrancy is generally less of a concern than in other blockchain environments. Why? Well, because it is allowed. It's not even possible. In simpler terms, the attacker can repeatedly carry out actions that are supposed to be executed only once. Repeat attacks are not applicable to Solana. Right, so that sounds like not a big deal on Solana, eh? Okay, to wrap this up, I'm gonna try to explain what the issue with this whole reentrancy thing is, because I'm not happy with just telling you, hey, yeah, that it's just not allowed without making a case for why it shouldn't be allowed. So I'm going to give you one example and I'm going to try and implement it. And obviously it's not going to work, but I'm going to do it with a self CPI and skip the evil program and do the evil program within my own program, because then it's going to work. Just to give you an idea, right? Okay, so the issue comes if I call my program, do some stuff, then do the CPI, but then I come back to my program and I do stuff again on state that wasn't properly persisted. So I work on intermediate state, kind of. And for that, I guess I'll need an account again, because I need to somehow have some state. Oh, okay, fine. I need that data account back. Let's do a program R. R for reentrancy. And I need a reward token, reward test token. Sure, why not? So let's do create token. Okay, we created this token. Now, this time copy again the R to target, deploy, key pair. And it doesn't need to call other programs. What else we will need is a PDA authority. Was it get program derived address for this program, and the seeds, not like I care, mint authority, whatever. So I will give the mint authority to a PDA of that program. Check this out. Log PDA authority. So this is gonna be the authority. I'm gonna put the PDA authority as read only. That's fine. I don't need to write to that. It's just used for signing. And then I'm also gonna need a receiver and a data account. Those two will need to be writable. Let's get back to our token. SBR token create account for this token. I'm just gonna create myself an ATA, so just gonna use that as the receiver. And we'll get to the user data account in a second. For now, let's just get it to work that I can mint tokens into here. So I'm still developing. This is not about the exploit yet. What I gotta do is SBL token authorize. That's the token. Mint authority, and I want to give it to this PDA. Current mint, new mint authority. That text is weird. It's the mint authority, the new mint authority. So if we now check, this token has this PDA now as the mint authority, which means my program should be able to mint tokens. So let's teach my program how to mint tokens. Vibe coding. Oh yeah, we'll need the token program as well. Vibe coding hard. Okay, so we will need SBR token. We will need a few more things. Receiver account, token program, oh yeah, and the authority, PDA authority. Those three things we will need. Then we can use a mint2. Oh, we don't need to have it checked, who cares? Pubkey, pubkey, pubkey. We also need the mint. Oh yeah, because we're minting tokens. Damn, we need the mint to mint tokens. God damn, okay. Token mint, have it. Count pubkey, that will be my receiver. Oh, and we always need the key owner. Wait, why do you need to, what? Why do you need to know the owner? Or is that supposed to be the owner of the token? Is that supposed to be the mint authority? That's weird. Owner is just a really bad word. I'm assuming this is the mint authority that it's talking about. I'll try. Signers and amount. This should be relatively easy. Let's mint 1 token. There, I want 1 token with 9 decimals. And that gives me an instruction. Now I can, as I did down here, invoke this instruction, hopefully. But I will need to invoke signed this time, this instruction. Again, can I just put in all of the accounts that will take it? It's okay, I'll just do that. I'll just clone, it's fine. And signer seeds, what do you take? Oh yeah, a slice of a slice of a slice of U8. Right, so have a slice. There's 1 signer, so this is the 1 slice. And there is 1, and that was mint authority as bytes. There we go. Slice a slice of slice of. Bam. There we go. And that, maybe, will work. Maybe not. We will see. Token minted. Let's build and deploy. Okay, so SBL token V8. I have no idea. 6? What versions are there? Like they don't correspond anymore in the... Did they still correspond here? Candidate versions didn't match. We have 8.7.6.4.3, 4.0. Okay. Okay, you need version 4. Using old versions. I know. I'm afraid of new versions. Or something. Expected instruction. Found a different instruction. Well, that's great. Similar names, but are actually distinct types. Okay, you know what? Fine. Use version 8 and use 221. Man, I tell you, dependencies is the worst thing about development. Never know which ones go together. Expected instruction, but found a different instruction. One is in Solana program and one in Solana instruction. I still didn't look at the new version because they changed something. They put it all in different crates. I need to make a separate video on this because this can't be so difficult. I mean, it is. It shouldn't be. The version I have 6 months ago. So the corresponding would be this one, version 7. Try version 7. But this kind of also broke, no? I don't know why that is. You need to specify it with the no entry point feature. That's it? Oh, you gotta know that! Huh. Okay. Wow, how long did that take me? Over 30 minutes. Holy shit. Okay, but we managed to find a working version of SBL token. We just gotta do it with no entry point. Okay, you gotta know this. Okay, fine. Good. Can we now test if we can mint tokens? See, I'm telling you, we're learning about other things about Solana as well. Not just Reentrancy. But we're gonna get back to Reentrancy after we've tested this. Let's see if we can demo minting tokens. Oh yeah, of course. Hold on. I'm not giving you the right accounts. What did I say I need? Sysva token mint PDA receiver token program. Sysva mint actually is writable because we changed the supply. Just want to copy token program because I'm too lazy to find it in the kit or to import the appropriate packages, so I'm just gonna hard code it like the sysvar. That's my style. So also mint, what did we have as mint? This was our mint. Okay, so with a mint PDA, can I now call this? So cross-program invocation with an unauthorized signer or writable account. Well, this guy is not a signer. What did I say though? Mint authority and seeds. Oh, I'm forgetting the byte for the bump, and I'm just gonna hard code the bump. Oh, hold on, I'm out. There we go. That's true, I had the wrong seeds. Oh, I need to redeploy, but at least it builds now. Okay, looking better though. Yeah, there we go. Mint 2, success, token minted, score. And then I die because of insufficient accounts because it tries to still call stuff or whatever. What is it trying to do then? Oh yeah, I do a self CPI then and then I fail. Oh yeah, that makes sense. I still told it you should self CPI once more. Let's not self CPI once more and see if that then actually works. There we go. Then it actually works and I can send that transaction. And we actually managed to mint a token. Score. Okay, but that's just prep. This 1 hour of development. Just prep. We can mint the token now. Okay, good. Let's go to the... let's first make the self-CPI work again. Because the issue I have with the self-CPI is that I don't have enough account keys because I'm taking out the ones that I steal here. You know, token mint, receiver, all of that. That should also go into account matters. Yeah, I'm just gonna do a bit of copy pasting. This is not the nicest way to write this. Matters, push, new account matter. And then instead of doing this, create an empty vec. Then I push all of them. Be like push account matter to account matters sysvar instructions. And we do that for all of them. Token mint, PDA. There we go. Still a bit of copy paste, but looks better. And while we have such a nice function here, might as well use that function here to push once again into account matters this account. Doesn't that look good? Meh. No. But better than more copy paste. Anyway, let's see if that would even work. It does build. It will probably also deploy. My question is, can I now do the same thing with a self CPI and do the same thing over again? Yes, I can. Look at this. That means now I call my program and you see that? Change +2. Because first I called my program, the program R was being called. I did the mint2, so the tokens were minted. And then I did a self CPI to the R program again. And I called again the mint2. So yeah, cool. That's working. And maybe you already see kind of the problem. Because here, I mean, here's not the problem yet. I mean, it's not obvious yet. Let me get rid of the... I mean, we kind of know how this works now. We don't need to log this anymore. So I could also throw away the sysvar, but whatever. Let's change it to the following. Let's create a user account. For that, I need another instruction. Let's say my first account is the user data account. And we need another instruction if this is an allocate points instruction. And in fact, we get the points to allocate from the instruction data, from the second byte. I just need a way to write something. It's also part of my setup. So I'm just allocating points and then basically user data, try borrow mutable, points to allocate. And I'm not even gonna care about overflows or whatever. So I allocate points and then I say okay. To allocate points, I don't need any of that yet. I basically just need the user account, generate key persona. And then as last time, I gotta create the account first. We'll give it 1 byte of space to use because that's the points. I'll just use 1 byte. It doesn't matter. You could use a U64 or whatever, it doesn't matter. And here, well, basically I just need this user data account as writable and the rest I don't even need because I don't read the rest anyway. Here the address and here I create the account and I call that program, but I need to call it with data depth 0 and allocate 100 points. There you go. Okay, just making sure I have that version deployed. Then we allocate points. There we go. Worked, 1 byte. Allocating points, that's all it does. And we can check that account. This is the account that was created. Account check this. 64. Does that make sense? D is 100. Yeah, that makes sense. D is 100 because lowercase a is roughly at 96 or something. Yeah, 96. So +4 is a D. That makes sense. And 64 also makes sense. That's hex 4, 6 times 16. Yeah, also 96. +4 is 100. So 64 in hex is also 100. So we have byte 1 written 100. Good. So there's 1 byte in that account and it has number 100. That's just the prep. I just needed to build this such that I have this one account, this user data account. Let's use this one that we just created. And again, I'm gonna put this user data account here as writable. And what I now want to do is I want to mint as many tokens as the user has points in his data account. So this represents the points that somehow the user can, accumulate through our program. And what our program then does in this instruction is you can basically mint tokens for points, and 1 point is worth 1 token. So in our mint2, let's first read the points that the user has. You can do that with user data try borrow. There we go. Now we have the points, and then we mint such that you can see points times 9 decimals. You can convert a U8 to a U64, or I just tell you you are a U64 into, as long as it works. And yeah, I could store the points as a U64. That would be the cleaner version as well, but whatever, it's just a demo. So should we try if that works? I mean, obviously that's gonna work, but what we then need to do at the end of our program, what I forgot obviously was that the user data, after it successfully got his tokens, we need to say that your points are now 0. Because you got the tokens minted, so now your points should be 0. Must not forget this, because otherwise the user could obviously mint unlimited tokens. And that will be bad, right? Right? You agree that that will be bad. Okay, good. We're on the same page. So deployed. Now let's test this. Uh-oh, insufficient account keys. What? Oh, because we're again doing a CPI. No, don't do a self CPI. Forget that. Just the user account and then mint. Good. There we go. That works. So look at that. We called the program. It minted us 100 tokens because we had 100 points. Tokens were minted and the points were also reduced. This one, we can look at that again. At the account should be 0 now. What? Well, that's not good. Oh, shit. I know why. I don't even get there because I stop here. See? That's the problem. It's also already hinting at the problem. So this is clearly not safe. Obviously, I should have done this right here after the tokens were minted and points reduced. That's the safe way to do this. Because that should be whenever I mint, obviously I gotta do the reset. But you know what? I'm gonna move this down. I only want to do this here. It's still together. I still only mint when right afterwards the points get deduced. So this should be safe now, right? Right? How do you do? Of course that's safe. That's super safe, right? So safe. So safe, can't be safer at all. No worries whatsoever. Because I'm now only gonna do this once after I successfully did a CPI to another program. And whether that be the same program or another program, it doesn't really matter. Could do the same program, but then I need to not forget that I also need to put in the user data account here. Or I first call another program like the program A. You know what, first let's call just another program. And we know that the other program only needs the sysvar and what other CPIs it wants to do, like here, like we did here. In our demo, say, we would then call program B, that should then call program C or something like that. Think that's gonna work? And only if we successfully did a CPI into program B will it actually do the thing with the minting tokens. If I don't do more CPIs, then it will still work, but I shouldn't mint the tokens for whatever reason. That's why I put it at the end now. No more programs to call, then it ends and it does nothing. But if I say, hey, do a CPI into program B, which then CPIs into program C, there we go. So we call it, program B is called, program C is called, program C has no more programs to call. And then once that's successful, I do the mint2 and tokens are minted and points are reduced. Let's check if tokens are actually minted. Yes, they are. And points are actually reduced. Yes, they are. Okay, So that worked at least. Good. So far, so good. And if I call it again now, then same thing happens, but I will mint, of course, 0 tokens because I have 0 points. That's what should happen. Okay, that's the framing of it. We have a program that lets us sell points for tokens or buy tokens with points, whatever. And now back to the issue of reentrancy. Let's assume that program B could do a reentrancy on program R. What could be the problem there? Look at the code. I'll make it big. This is the code. You clearly see everything. We read the points. We do the CPI. We create the mint instruction and mint. We reduce the points. We finish. What could be the problem if Solana would allow reentrancy? What could program B or even program C do? Well, guess what? They could call this very instruction again. And what would happen? Well, the points would be read again. And at that point, the points are not overwritten yet. Because the points are only getting overwritten at the very end. Not at the point where the CPI is happening to program B. So at that point, the points are still there. And obviously, program B can't change the value of the points. Like it can't write to that account because it's not owning that account. But it could just go back and call it again. It can't because that's not allowed. But let me demonstrate what would happen if it was allowed. Or if the programmer of the program here is a bit stupid and doesn't check for self CPIs or even implements them like I'm gonna do now. I just needed to change this such that I can call the old programs, the A, B, and C. But if I would do a self CPI, I'm gonna use the exact same accounts, all of those. I have to put them back in just so that all works, just so it has the correct accounts above as well. And then with that I can do a self CPI. I just tell it, hey, let's not call program B and C, let's just call the program itself again. What do you think is gonna happen? Well, first, nothing because we still have no points. I gotta get points again. Can I allocate points to the same account? Allocate points again to this user account. We don't need to recreate it. Just use this to allocate another 100 points. Allocate points again, just so we have another 100 points in here. And then let me demo this exploit. Success. Look at that. 337. Look at what is happening here. We're just calling the program as we usually do. Oh! And we're getting 100 points as we usually do. Because I once again forgot about the thing that I said earlier. I'm stupid. Remember how I said it should only mint tokens when it does a CPI? Allocate points again. I have points again. Because I forgot about that part. Let's let it then call program C as well. Yes. Because that's my stupid logic. But anyway, with that, let's check that. Let's do this. Look. What? Unsupported sysvar, I'm calling program C. Yes, I know. Because now you're having those stupid things. Can you just call the no-op program? Or easier, can I just fix our program that we just do like a bad programmer, fit all of that shit into an else branch, that we only do the CPI if there is an actual program to be called, and otherwise we just don't do it. That makes more sense. So no more program to be called, but then we still do the token mint too, just so it doesn't end and I don't force it to do another CPI. Okay, anyway, yeah, like this. Does it get complicated now? Did you already completely lose sight of what is actually happening? Let me repeat for you. We have a program that reads points from a user account, just a 1-byte thing, and then it might do a CPI into another program, or in this case, into itself again. It does a self CPI, And then it mints those tokens. For every point, it mints a token. And then it resets the points to 0. And what will go wrong here now, of course? Well, we have 100 points. And when we do this reentrancy thing, how many tokens you think we're gonna get? 200! That's right! We get 200 tokens with 100 points. Reentrancy. Ow. And of course, I could keep playing that game. I mean, afterwards, we have 0 points. I mean, that works. It sets it to 0, right? I mean, I have 0 points now. I will need to allocate myself more points. Let's say I somehow get another 200 points. There you go. That's 200 now. And I could be stupid and do another self-CPI. So another reentrancy. And maybe even another reentrancy. Then I will get how many tokens? That's right. 4 times 200. Which is 800 points. Tokens. 800 tokens. That's even more than fits into 1 byte. Wow. And why? Well, yeah, because the program, our reentrancy program, reads the points, but then does the CPI to itself, reading the points again, doing another CPI, reading the points again, reading the points again, and only then minting all of the points to tokens. So it's remembering state, earlier state, that it then just... And that's exactly the problem with reentrancy. The program might not have written all of the things yet, like persisted everything to state, because we're in the middle of instruction execution still. Tokens minted, points reduced, points reduced. And then we always set it to 0, but we can't go lower than 0. We're minting tokens that the user don't have. They don't have the points for that. So that's a bug. And to fix that, we would need to do this before the CPI happens. So this state would need to be persisted right here. When we read the points, we need to directly set them to 0, such that we never later work on other state. But it's important that this is actually written into the serialized accounts slice, because we're still not serializing the account back. We're still in the middle of executions. We're still in the middle of the instruction. So the only way I write it into the serialized accounts that I get as the thing that comes in here, those accounts, they point to somewhere. We've looked at that in depth when we talked about the entry points in previous videos, which you can find up there. But if you were using Anchor, for instance, even though Anchor does write the data back to the account automatically, but they temporarily store it, like here with those points, and only at the very end then serialize that data back onto the account. So with Anchor, this would also not work. But here, I think that should work. I'm gonna allocate myself points again. Let's say I allocate 34 points. And I have 34 points in here, because 32 plus 2. I redeploy my program such that we do this thing that we write it to 0 right after. And as I said, that's still within the instruction. It's not actually written in the account yet at that point, but it's in that serialized slice of accounts and instruction data and program ID that we get. And that should already fix that, I think. So if we now demo that exploit, I'm actually curious if that would fix it. I think it would fix it, but I'm not even sure. I think I should only get 34 points now, tokens. And I get, yes, I only get 34 points now, bringing the total to 1337 tokens. Fixed it. Even though the program does do self-CPI and self-CPI and self-CPI, but there it then always reads the points are 0. And then it only means 0 and 0 and 0. And only at the very outermost instruction, the top level one, it means 34. Nice. Very nice. I hope that you understood what the issue here is. Working on temporary state we need to always write the state back before doing a CPI that works, on the same state. But since it's our account, only we can read and write from that anyway, right? So we wouldn't expect that another program can just change that. But another program could, do a reentrancy into our program while we're still operating on that. And that's exactly why they're not allowing reentrancy. I think there might be other reasons to disallow that, but that's one exploit that I can think of that works through the reentrancy and is not allowed on Solana because you can't do reentrancy unless you're doing self-CPIs and you're stupid enough to call your own freaking program from your own program, but then it's your own fault that you run into issues like that. You should have thought about that. So yeah, that's that. And I think we can leave it at that. So, yeah, it's been 3.5 hours anyway. Again, took way longer. After an hour, I was like, well, I'm pretty much done here anyway. Boom! 2.5 hours later. I'm not done yet. But yeah, that's usually how this works. I usually go from one thing to the next. But hey, it was fun to play around with this. We learned that reentrancy is definitely not allowed on Solana. Not from top level and not from anywhere within an instruction. So in one instruction, as soon as a program CPIs into another program, it's guaranteed that it will never come back to the first program. That is guaranteed through the no reentrancy runtime checks for that. And that's pretty cool. Might also be annoying because it limits your use cases for some things, but it also adds security because mitigates some things. As we saw, a malicious program can't just recall your program after you've partially executed stuff already. So that's nice. And that's important knowledge to have as a Solana dev. You need to know what is possible and what is not possible so that you design your program accordingly. Even if you want to, you can't design your program to call another program and then call your first program again. That just doesn't work. It's not allowed. And so you would probably need to split those programs. And then if they need the same kind of state, then you need to figure out some other way to make authorities, or have the first program being called the main authority and just pass on the authority because, it can invoke signed and stuff. It's fun. It's fun to play around with those things. I hope you learned something. And even if it's just how to get the SPL token crate to work with your Solana version, you gotta import with no entry point. Things you just gotta know. But you find the answers on Stack Exchange usually. That's good. Yeah, cool. Was a nice adventure. I think I'm gonna call it here. That's enough. You can watch other videos here. Like this one if you enjoyed it. Subscribe if you haven't done that already. And I will see you in the next one. Until then, ow. Bye-bye. Next one, we're probably gonna look at the new versions of the Solana program crates. Because that changed and I still don't know what changed. And because I'm still using old versions just because I'm afraid of the newest one. So I'll need to look at the newest one in the next video.